In order to make full use of our continuous compound interest formula, we're going to need to use the natural logarithm. So we'll do just a little bit of quick review here before we use it to help us in an example. So the natural logarithm is a logarithm base e. So when we talk about, say, the natural log of x, the way that we are going to notate that is we're going to say ln of x. So you should have a natural log button somewhere on your calculator. This is just a logarithm base e. So if you wanted to write this using kind of standard logarithm notation, you would say log base e of x. Now, we're never going to write it like we have it over here on this right-hand side. I just wanted to write it so that you could see it once. Whenever we talk about the natural log, we are always going to be using this notation, this ln of x. So what's so helpful about the natural logarithm, among many other things, is it allows us to solve exponential equations. We can't really solve exponential equations, or at least some exponential equations, without the use of the natural log. So it really helps us. So just to quickly look at an example here and practice using the natural logarithm in case we haven't used it in a little bit. If I have the equation 12 equals 4 times e to the 0.09t, if I want to solve this equation, the thing that makes this an exponential equation, first of all, is that my variable t lives in the exponent of some number, and that number happens to be e here. So if my variable lives in the exponents of some number, I'm going to have to use a logarithm of some kind to solve this equation. But before I can do that, I want to get this piece by itself first. I want to get that e to the 0.09t by itself first. So the first thing I need to do is get rid of that 4. So let's divide both sides by 4, and I'll end up with 3 equals e to the 0.09t. Once you have that exponential by itself, now we're going to go ahead and apply our natural logarithm. So I'm going to take the natural log of both sides of my equation. So we'll have natural log of 3 is equal to, on my right-hand side, natural log of e to the 0.09t power. So I'm just applying my natural logarithm to both sides. Now on this left-hand side, natural log of 3, that is a number. You can, it's an ugly number, but you can type that in a calculator and get back a big, long, ugly decimal if you wanted to use that. I'm just going to leave that as natural log of 3. On the right-hand side, though, what ends up happening? Well, natural log and e, these are sort of opposites, similar to addition and subtraction. If you think about what happens in solving equations when we use the opposite, well, they cancel each other out. So those two are going to cancel each other out, and then I'm left with just whatever is in my power. So in this case, it's that 0.09t. Now I can continue on solving for t just like I normally would. So in order to finish up this equation, I'm going to divide both sides by 0.09, divide the left-hand side by 0.09. So that means that t is equal to natural log of 3 divided by 0.09. Now this is the exact answer. Most of the time we're going to want an approximate answer as well. So we're going to have to use our calculators to help us out here. Natural log of 3 divided by 0.09 gives us, let's say, 12.21 if I round to 2 decimal places. So this is my approximate value of t. Now be careful when you're typing this into your calculator, especially if you have a graphing calculator, if you want to do this all in one step. What your calculator is going to do is it's going to open a set of parentheses here for what goes inside of that natural log. If you're going to do your division in the same step here, you want to make sure that you close those parentheses around the 3 before you divide by 0.09. Otherwise, you're going to get the wrong answer. You're going to do things in the wrong order. So just make sure that you close those parentheses. The other thing that I will point out here, I said earlier that natural log of 3 is a number. You can type that in and you can get a decimal approximation. However, I strongly recommend not doing that. And the reason is, if you were to type this in your calculator and get a decimal, and let's say we rounded that to 2 decimal places, just like we did with our answer right here. Well, when we round to 2 decimal places, we're introducing a little bit of error, a little bit of a mistake into our problem, which if it's at the end of the problem, I think that's kind of okay. That's going to happen if we want to work with more manageable numbers. But if we introduce a mistake here in this step, well, my next step, I still need to keep working with that same number. I need to divide by 0.09. So I'm working this with this mistake, and then I'm going to do more with it. I'm going to divide by the 0.09. What ends up happening is this mistake sort of snowballs, and it kind of builds on itself. So what might have ended up as a small mistake when we rounded that natural log of 3, as we work with it more and more, it can lead to us getting a different result here at the end. And oftentimes, when we're working with very large sums of money, like we are here, and we're working with $10,000 and $12,000, a little teeny tiny mistake can make a really, really big difference. So my advice to you as you're working through these problems is not to round anything until the very, very last step of your problem. Please, please, please wait to round these until the last step. Once you have t, or whichever variable you're solving for, once you have that variable by itself, then you can go ahead and type that into your calculator and get a decimal approximation. So one more example that I want to take a look at here. It says, using the CD from example 1, how long will it take for the account to be worth $12,000? So I want to use all of the details that we had from example 1. So if I scroll back up here, when we were looking at example 1, we had, let's see, an interest rate of 1.25%. and we invested $10,000. So I'm going to take all of this information that's right here. Let me copy this, and I'm going to bring it down to our next problem that we're working with here. So here I'm asking a slightly different question. It says, how long will it take for the account to be worth $12,000? So in this case, I don't actually know what t is. T is going to be the variable that I'm solving for. But I know at the end of all of this, I want the account to be worth $12,000. So I want my ending balance to be $12,000. Well, my ending balance, that is A. So this is the change I need to make here. So I'm not going to be solving for A. Instead, I'm going to be solving for T. So I'm going to take all of this information that I have and plug it into my continuous compound interest formula, which says A equals P times E raised to the RT power. So A, that was 12,000, equals P is 10,000, times E raised to the R, that was 0.0125, times T. I don't know what T is. That's my variable. So I'm going to be solving for T. And from here on out, I'm going to be trying to solve this equation. And the steps, the process is going to look really similar to what we did last time. So my first step here, I'm going to divide both sides by that 10,000. Remember, we need that exponential part by itself first. So we'll divide both sides by 10,000. On this left-hand side, 12,000 divided by 10,000, I should end up with 1.2 equals e to the 0.0125 t power. And now that I have this exponential part by itself, now I can go ahead and take the natural log of each side. So we'll say the natural log of 1.2 is equal to the natural log of e to the 0.0125 t power. Well, natural log of 1.2, that's a number, so we're just going to leave that as natural log of 1.2. On the right-hand side, I know natural log and e cancel each other out, so I'm just left with 0.0125t. If I want to finish this equation up or finish this problem up, I'm going to divide both sides by 0.0125, divide by 0.0125, and I'm running out of room just a little bit here. But I should end up with t is equal to, we said, natural log of 1.2 divided by 0.0125. That's something that we can go ahead and get a decimal approximation for. So natural log of 1.2 divided by 0.0125, and I end up with 14.59 years. We want to make sure we include a unit on that as well. So 14.59 years, this is our value for t. So the natural log allows us to use this equation to solve for other parts. Before we had the natural log, really all we could do was solve for a, but now I can solve for these other parts. I can solve for r, or I can solve for t. And we'll take a look at a couple more examples in our next video.